Our next speaker will be a clinician, and that will be Phil Edholm, who is an active model runner. He is part of the California Central Coast ON30 modular group and the ACCRS club that operates the layouts at the Alameda County Fairgrounds. While his primary focus is O and ON30, Phil also models an HO. Phil is the superintendent of the NMRA PCR Coast Division and helping drive the NMRA and railroading forward as a hobby. Phil Edholm is a retired visionary, a leader in the enterprise communications market. In 2007, he was recognized by Frost Sullivan with a Lifetime Achievement Award for growth, innovation, and leadership in telecommunications for an essential role in creating the VoIP industry. He has been recognized by the IEEE as the originator of the Edholm's Law of Bandwidth, as published in the July 2004 issue of the IEEE Spectrum, one of 4 laws of technology. He was the leader in the market adaptation of the WebRTC and the technology underlying much of today's video collaboration solutions. Phil has been granted 18 U.S. patents and holds a Bachelor of Science in Mechanical Engineering and Electrical Engineering from Kettering University. Phil, with that, I turn it over to you.
Wow, that was longer than I expected. It didn't look that long in the text I said. I didn't realize I said something that long. Okay, so very quickly, I'm going to talk about 2 buildings that actually and a third that were built 2 different ways, one with acrylic and one with 3D printed framing. So show you a couple of pictures. First off, these were on one of the video loops or slide loops a while back. So 2 buildings. The building on the left is actually the one that's acrylic framed. The building on the right is the one that's 3D printed. They're part of a warehouse scene that's on a module. I'll show you that in just a moment. But that's basically what we're going to talk about today. Very quickly, background in modeling. I started getting involved with the California Central Coast about 10 years ago, and I got back into modeling when my career began to slow down a little bit. And then I do at the fairgrounds in Pleasanton, we have an HO and an O layout. I'm part of the O layout there, and that's actually, we get about 60,000 visitors a year. So it's one of the most visited layouts in the US, being on a very large fairgrounds. My modeling basically is focused in narrow gauge, a little bit of an evolution, and that kind of drives what I'm going to show you today. Up above the upper 3 pictures, the first module I built that was kind of a Sierra themed, which is where my headset was, but I got into this group in California Central Coast and then began to build modules. And if you look at the 2 in the bottom, the one on the left is a fairly photographically correct of the 2 portals of what's called the Mission Hill Tunnel, which is underneath the Mission in Santa Cruz. And the right is a reimagining of Wilder Ranch, which is a park that used to be a dairy farm right north of Santa Cruz. So I started to make basically modules that fit that. And that led me to just build a module that is about 12 feet long, 2'4" wide. You can see a picture of it down on the bottom here. The 2 buildings that we can talk about today. There's a third building that needs to still be built, and then there's a whole scene over here, which is a fuel dock for ships to arrive. This module is actually a thought process or reimagining of what's called Moss Landing. If a harbor had been built there in the 1920s, that actually didn't happen, and in much more detail I won't go into. When I built these, I had a problem and wanted to build a module where you could take the buildings off. The problem when you put these things in a trailer and they bounce around in a U-Haul trailer, things just fall apart. And so my thought process was, if I built boxes that were sized to a block of 1 by, basically 3/4 inch plywood, then if I put masonite on top of that, I could build bases for the buildings. So these are the 2 buildings I'm going to show you here. This was basically the bases of those. And this is the 3D printed building. Basically, it just lifts out, and I just lift it by grabbing onto the ends here. It's quite strong, and you can pick it up with 2 fingers on each end of it and pick it up and put it in a box. I transport it in a tub, and I'll show you that in a second. Oh, I just jumped there. So then one of the things I did was I gathered a whole bunch of detailed pictures of the area. This Moss Landing was very interesting. The Pajaro Valley Consolidated Railroad ran through. If you look here, this is actually the kind of the mainland, and there's a Y here with a railroad bridge and a regular bridge. This is the Y. These pictures were all taken during the 1906 earthquake. They documented all the disasters. It was a great time to get pictures of the past. And then a bunch of things for the pier. Just as a side, I keep all this information in a big PowerPoint deck. It's a great way to keep information and pictures together on a modeling project. And you can see kind of circled in red there, those are kind of the designs of all the buildings. And so the buildings on these modules were all designed in PowerPoint and laid out. And you see basically the two buildings that we're going to talk about on the left. The upper one is a cannery that's yet to be built. I need to finish that one. And then on the bottom right is a small building that's part of a model of the Standard Oil fuel pier in Monterey. So these were the original designs. These were the two buildings. I decided to build these in acrylic. My thought was, if I build them in acrylic, glue them together, glue them on with epoxy, the masonite, I'll have really strong structures that I can take off and they won't get damaged. So I actually built all three buildings in acrylic and started building those out. Acrylic, by the way, cut on my table saw. If you set the blade just to the thickness of the acrylic and push it very gently through, you can keep from cracking it. And then cutting doors out, I've got a scroll saw that I've had for many years. It seems to work really well for cutting the acrylic and where you need doors and that. The first building I built was this one, which is the red building. And it was actually done the way I originally anticipated building these, which was I made an outside where I cut using board and batten siding, basically cutouts where I was going to put windows. And those were cut actually for some tissue window frames. And then I cut out where the door was, and that door was already cut out in the acrylic, so this matched. This wood then was glued on using epoxy. So I mixed up small batches of epoxy, spread it on the wood, glue it on, just make sure you didn't get close here where the windows were. Then after I got done with that, basically the outside was finished with ink to darken it with alcohol and ink, and then dry brushed red. Then on the inside, basically repeated the same pattern and did it on just a scribe siding. So that was then glued on, it was then stained, and then I put in a base, which is down here. What I found was very interesting. If this is a microengineering ON30 track, and it turns out that this 1/8 inch acrylic that I was using for the walls is actually exactly the same thickness as the ties. So I was able to put that in, and then I put a couple of rails actually glued just with ACC on that, because I wanted to have a way to get things from inside the building out to the dock, which is outside here. And then you can see basically the floor stained a darker color, and then I started adding on the walls, furring strips across glued first. All of these are finished off, individually as pieces, then glued on, and then some, square pieces representing the framing. One thing I did was I put shoes here on the corners, and those actually get caught by wires that are attached to the roof trusses, and that actually brings the power in. So this is basically what the building looks like on the dock installed. Kind of the tracks in here line up with some tracks that go out on the dock. This is where cars normally sit. Kind of see pretty reasonable. And you can see what happens with the interior, and it's really interesting that, when you look here, you can see the thickness of the wall. But when you look other places, you really don't see it. And, what's interesting then is, look over here where the window is, you really don't notice much, and the framing is what draws you into the room. Built a very simple little ramp system here. And when you look at it from the top, most of the things in here were 3D printed. Obviously, there's some cast parts, the desk here, this little piece over here, and I think the clock, but most everything else tried to 3D print or create. One thing that is interesting, I'm not going to talk much about it today, but all of these are done using 6x4 photos and actually producing 1200 DPI images. And for 70 cents, you can get, 100 posters for your buildings. What's interesting about this as a construction technique is you're using the 1/8 inch framing as the window glass. and that 1/8 inch acrylic is there. So what I did was I took each of the window frames and I sanded them down until they were almost sanded all the way down to the mullions. So if you actually look at it, the mullions down here are on the acrylic. The ones up here are slightly off, but you really can't see it. What's interesting is when you look through the windows, they actually look really clear and you can really see inside. This is a bit of focus here on the camera. Um, but when you look at it, if you look really close, you can actually see that extra little bit of cutout. But when you look at it in the general model, it's almost impossible to see. So I was very happy with the way this turned out, and I've actually got a couple of pictures. I think I took them out of the deck that show the ends where it's wider. It's very hard to see that it's that thicker building. Then I decided to do the roof. The roof was done the same way. By the way, you notice these little gussets here. The wire that goes around there supports the lights. When you slide it down, it contacts with that shoe and the lights come on. Basically, these were 3D printed, and I sat looking at that and said, well, gee, if I can 3D print the trusses here, why can't I 3D print this building? So the second building that I built here is one that's 3D printed. It's based on these warehouses. Only picture I've ever been able to find. Translated that down into something that's compressed into 20 by 8 inches. So this is, the other building was 12 by 8 inches. This is 20 by 8. So basically did this level of design, and this was again all done in PowerPoint. It's a really nice drawing package if you can handle fractions a little bit in your head. Then what I did was I broke that into wall pieces that could be 3D printed on a filament printer. So if you looked at these walls, they're actually 20 inches long. So you basically say 8 inches in the middle, 8 inches will print as one piece, 2 6-inch pieces. So this became 3 print jobs essentially to print this wall. The actual design of the wall was all done in FreeCAD. And I actually did it in the framing with the framing designing. So you kind of see that this window that was here when I laid out the framing actually, or excuse me, this door moved over to right here. Down here you can see the door where it's set based on kind of the stud, the positions of the studs here, or the major posts there. So the design of this is actually pretty simple. This is what you get as a wall. You could do this either in Tinkercad. I did it in FreeCAD, and I'll show you the steps. The one thing here that I did note is I buried this lateral support here into the wall. In the building I'm going to show you, that's actually that pure fuel pier building. I actually put it on top of the wall, and it gives you a lot more three-dimensionality. The difference is these were printed with the side facing us down. When you put these up, you have to face them on the other side, and then you get a support under here. But when you pull it off, you don't see anything because it's on the back side. So, to do this in FreeCAD, you basically create a box that's the wall. You take away what you don't want. You add in, for example, I just made this where the window was, added in the position of the top and bottom boards for the window, added in a cripple up here, added in that cross piece. And then these were added on for the trusses. So up here at the top, put these pieces on. So when you put the trusses in, the trusses will sit down into there, and then you can put a pin through to hold them in place. You'll notice this end piece here is actually half the thickness of the major posts. The reason is that the walls break there, so each one has that on it. And then you can very easily put these pins in, so you can put a wire in place to align them. So what I did was just basically took a little bit of epoxy, ran it down this side, put 2 pins in, squeezed the other one, those cheap clamps from Harbor Freight on them for about 4 hours. And the wall, you literally can, I had one that I passed around in clinics, and after about 4 or 5 clinics of whipping it around, it finally started to crack. But basically, this is, 2 pieces up here, 3 pieces here, you can see, and then they're joined together down here. You kind of see a little bit here with the pins for the trusses. So this is basically my first attempt, and I got this all done and realized that I screwed up and I didn't have any lighting. So the next step was to come up with doing lighting on the trusses. So this actually adds a lighting truss off. as well as rods here to hold brass wires to run across and carry the power. So these were printed, as you can see, down on the bed. So these print up. Then they were finished. I'll talk about finishing in a second. What you see here is these brass wires carry the power across. The lights get each side, and there's a resistor in one side. So one side of the building is plus, and one side, the other side's minus. And this is kind of an in wall, how it looks completed. A few more pictures on how to do a pony truss. And you can see here, this was trying to show the alignment pins. What you can do is very easily put an alignment pin in both of those, and those just pin together, and it sits in and looks really pretty good. Did an office the same way. The office is you actually pick it up and throw it around. It won't break. But you basically print it out, then covered with wood, with real wood siding on it. All the siding here is wood, and I'll show you about that. So from a texturing and coloring, the thing that made this building really interesting was you had gray plastic. And is how do you turn the gray plastic into something that really works in terms of looking like wood? And the first thing, somewhere I heard about the idea of using filler primer as a way to build depth. And so if you think about it, if you print on a 3D printer, you've got, if you think about it in cross section, you know, a 4x4 is a square, and it prints as a bunch of layers. So on the sides, you've got all those layers. And it doesn't really quite look like really like, you know, wood grain, but you're not looking at it head on. You're looking at an angle back on a wall. What really matters is the face that you're going to see. So what I found is you take the wood, put it on some, you know, boards with some masking tape, and spray it with about 4 coats of this this filler primer. What it does is it builds up a layer. This is the stuff that's designed to, you spray it on your car and it fills the scratch in, and then it sands smooth. It builds up enough that you can take a razor saw and drag it along, or whatever tool you use, and you can create really nice wood grain effects. So when you look at it, it actually looks like real wood. And then the key to finishing anything like this, I'm sure everybody's kind of aware, is the first thing was to finish the siding. It was mahogany and brown shoe dyes and alcohol. I was trying to get what's a weathered redwood look. You know, out here in California, in this area especially, almost everything was built out of redwood. So the siding on a building built in the 1900s, early 1900s, would have been built out of redwood. And redwood, if it's in the sun, goes gray, but if it's indoors, it just gets a really dark kind of reddish brown tinge. So basically tried to finish the wood as individual boards to match that, and then how to finish this plastic to match. I found that the best way to do it was use this caramel, which is kind of almost a redwoodish tone. Sprayed everything with that, and then dry brushed it. And by the way, you can get the PDF of this at the end, but basically used a number of different dry brushes. The one thing, by the way, if you are, as I am, not a very good dry brush, I'm an engineer, not an architect, not an artist. I found these Army Painter dry brushing sets, which you can get on eBay. I think on eBay or Amazon. They have kind of a rounded tip, and they work for me a lot better dry brushing than anything else I've tried to use. So then the exterior wall, it was glued on. It was brown because that was what was on the inside. The outside was then washed with alcohol. Then that was dry brushed with, you know, artist tube acrylic, the bright white, and then wire brush for effect, and then a little bit of additional weathering on it. We're trying to create as a building that would be well maintained. This is a Spreckels warehouse. Spreckels had a huge beet sugar refinery, and the idea is that he's shipping sugar through here on a boat up to the further refinery in San Francisco that took the raw sugar and finished it. So it would be a well-maintained building. The floor, what I did with the floor was actually put it onto the masonite. So if you kind of think about it, this is one of the doors here. Right here, this little gap is where the wall is going to glue down to. Put down scribe siding, again, epoxied it down. One of the neat things, if you epoxy siding, scribe siding down onto something like masonite, you can take your razor knife and run down the boards and cut them much deeper, and it gives it a much deeper effect than you normally get. You got to be a little careful. I always try to do it with a straight edge, but I often do it just directly. The other thing I found was that if you grind off the tip of an X-Acto blade, you can grind it down to just the right thickness so it'll fit and just make these cuts between the boards. So combining that with, you know, a very sharp pencil to do some nails gives it a really nice look when you get into the kind of the finished model. Um, the last thing that I had to do was the roof. The roof is 7 pieces. It's an awful lot of CAD work to go in to figure out how to make all these angles come together. And it was then completely epoxied together. There's some gussets here that load between these two. And then it was covered with northeastern shingles. This is the northeastern corrugated siding cut down, spray painted gray and finished with Dr. Benz and some acrylic washes. This actually hasn't been had final weathering. Kind of do the rust weathering individually on these, but then do more heavy weathering that would run across between the different ones when you finish. After doing the doors on the red building, which were actually done with engine house hinges from the locomotive engine house hinges, I found that when I moved it up and down, they were all falling off. And I looked at this and realized that I had about 8 of these doors to do. And so I actually kind of wussed out and I made them open in, which made it really easy. But on the other side of the building, I had to do sliding doors. So I decided to 3D print those. And again, this kind of stuff actually works out pretty well. So basically, I designed a channel here. And inside that channel, you can see that there's a hole to run a rod through. I was originally just going to use a rod, but I happened to be at our local hobby shop and bought a carbon fiber airplane rod. And it turns out there are holes up here at the top. You can kind of see them over here in these little loops. Well, those little loops go on that carbon fiber and they slide really well. And it works very well as doors. The last thing was needed to create a pile of sugar. So I bought some sugar sacks from Grant Line, proceeded to replicate them in resin because I could not, quite frankly, afford the 1,000 or so that I needed. I started doing that, and then I 3D printed a carrier for size. Made a lot of sugar cubes, painted a lot of sugar cubes, sugar sacks. Then decided that I needed to have a way to get up to the top of the sugar stack, so ended up designing this piece that's actually kind of a ramp to get up there. And then ended up for these on the sides here, versus taking individual sugar stacks, what I did was took again a new batch of the Grant Line ones and built stacks. So these were super glued together. And then I built a silicone mold and that we could resin print these. So these are all resin printed stacks here that go around the outside. And it looks really good when you get done. So these are those 2 buildings. Kind of some other pictures of them on the module. I should take some more pictures. It's a lot more scenery done on it now. These are the sliding doors on the back. They move very well. This was done so that you could have a railroad the track right up against the building. I didn't have to have another loading dock there. And then some pictures inside of the workers loading there, the office. And this is kind of a view of it from the top. So basically, if you look here closely, you can see there's a post right here that's kind of 3D printed with a brass rod, and there's another one over here. And the wiring basically daisy chains to there. So this one runs to here and then runs to here and then runs over to here. Or actually from here to here, and then on this side from here to here to here. These 4 trusses here are actually removable. And so I'm gonna turn my camera off, just show you. I wanted to show you. I think my background is reasonably. Let me turn my background off. I'm sorry. If I don't turn my background filter off, you won't see anything. So just to give you an idea of how strong something like this is. So this is the roof for the building. And as I can pick it up from one end and just hold it, it's very strong. And similarly, this is the building. So you can just pick it up by the ends, and I can flip it up here so you guys can see down inside. So, again, it's one of the things it does. For buildings that are going to be on modules where you have to have where you're going to have a lot of handling, it really is helpful. So I want to show this just because I thought this was interesting. This was the third building I built, and by now I figured out that one of the big things that you get with this 3D printing is you can very easily make layering in your walls. So this structure actually, what I really want to show you here is if you look down into it, notice the depth you get. Now, this is a small building. It's about 3 inches by maybe 4 inches by 2 inches. What I wanted you to do is look over here and notice what you get in terms of the way it looks. The diagonals here are on the top of the wall, again printed so that they've got on behind them they'll have supports, but you pull it off. You've got the posts here, and then what there is there's a separate layer of furring strips. So when you look down in here, you actually see a gap between the aluminum siding and the framed wall, which is what you'd see in a regular building. And this is done by basically creating 2 sets of walls. There's a framed wall, which includes the diagonal and the studs, and then there's another piece, this piece that would go with it. Actually, this piece goes with this door, that basically is the furring strips, and those were then glued together and then glued up to build the building. And again, I think when you look at it, it's really pretty cool inside. So anyway, I don't know if I did that in 45 minutes or not. I hope so. I hope it was interesting. I put things about learnings and regrets. Printing, make the sections smaller than you think. You can glue them together. You can design some things that way. I do find that the gray or lighter filament, and the gray seems to work very well. The more darker the colors are, the more pigments are in it, and it kind of changes the way it flows, it seems. Again, print it flat. Like I said, the way I would do it now is print it with the outside down so that you get the inside, you get that, the raising up of the diagonals. One of the things I found, by the way, that heating doesn't solve warping. If you look at this piece here, it had a little bit of a warp in it. I put it in the oven, figuring I could flatten it out in the oven, and that did not work. The only thing I found that works is I've got a fairly hot water heater, and I'll fill a bucket of water up with really hot water and hold a part in there for about 30 seconds, and they just start to get pliable, and you kind of do a little bit of straightening things out. But generally, once you have a problem like that you have something that gets twisted, it doesn't work. Lots of test prints, lots of pieces that got thrown away. The filler primer, I find it's really good. And this is, if you wanted to, for example, 3D print a frame for a flat car or for any sort of car, on the outside of the frame, because on the inside you wouldn't see it as much, but especially on the outside, do the 3 layers of the filler primer, and you'll actually get wood grating on the sides where people see it. Excuse me. Dry brushing is really important. The semi-gloss, I was worried about semi-gloss paint, but that caramel was semi-gloss, and after dry brushing, it took the gloss away. So one of the things that's interesting is you can use the right color, even if it's semi-gloss, if you're going to dry brush it. I think I would rethink the way the base was done. You can be really accurate when CAD with window dimensions on the framing. You can be within 0.2 millimeters. I would have made the roof members smaller, but I decided it wasn't worth going back and redoing the whole thing. It would be nice to have the trusses be removable, have some sort of contacts when they dropped in. And then I printed things a little too high. Anyway, so that was everything. You can, there are 2 PDFs or 2 URLs up here, and I'll put both of these in chat. The upper one is, and you can remember, if you remember tinyurl, tinyurl.com is a place that shortens URLs. So just tinyurl NNG 2023. So basically that's the PDF of the presentation. The lower one is one I actually did with TSG Multimedia, which is a little bit longer version of the same presentation. Any questions, comments, concerns?
Hey, thank you, Phil. That was great. Really some interesting techniques there. Let me relay a couple of questions that appear in the chat room. Jim Curran said, do you get any crazing or fogging on the acrylic from the epoxy?
No, one of the things I did, so when you put the epoxy on the wood, I kept it back at least a quarter of an inch, 3/8 of an inch from where the windows were. And so, you're not actually getting any glue really close to where you're going to be looking through the windows. And then what I did when I put the tissue window frames after I sanded them and they were painted, and I went to install them because they just go in there into the opening. I just put those in with canopy glue. I have to say I'm a cheater. I use canopy glue for everything. I find it's a very effective glue for almost everything. And somehow it seems like it comes in a small bottle and it seems like it should be precious, but I've seen too many white glue models at the club in Pleasanton. The white glue falls apart after 30 years.
Yeah, Jim further says that similar to what you did with the double brass wire from the knob tube wiring, I found some double-holed flat beads that worked perfect for this. The ones I found were called Mayukai half Tila. Had I found on something he found on clearance at Hobby Lobby. Bill Hobbs mentioned how long would it take to print a rafter or a wall section?
So the thing that's interesting about these things is that they're not a lot of volume, right? So the thing about filament printers is it's really just a toothpaste tube, and you're squirting, and you squirt at a fixed rate. So if you think about a wall with a truss, for example, or a framed wall, it's basically if you're doing it in O scale and you want to make it 6 inches. 6 inches is the 6.35 millimeter kind of thing. So basically, what you do is you essentially make it that thickness. And if you look at the volume, it's an hour and a half, to print a truss. So a truss for an 8-inch building would be an hour maybe.
Okay, super.
And a wall side is probably a couple of hours, hour and a half to 2 hours. And so, the only challenge is when you realize that you printed a bunch of stuff and you have to go back and make a change that applies to all of them. It's a lot of reprinting. So you get a lot of throwaway. On the other hand, I probably doing that building used one $20 roll of PLA.
Hmm.
Oh, and the
Okay.
one piece of advice, by the way, is don't leave these things in the sun.
Okay. I have a question. You mentioned something about posters and 70 cents gets you X number of posters. Is that a location or an address on the web page
No,
somewhere?
no. So basically, I one of the clinics I do, I think I'm going to do it at the NMRA convention. I don't know if I probably should sign up to do it at the narrow gauge convention. There's room still. Is how to use PowerPoint in modeling. You saw what I did with collecting stuff.
Yeah.
One of the things I do is PowerPoint's a great drawing package. It's a slide package that really is a drawing package. You're hiding behind it. And what's interesting about PowerPoint is you can make the slide any size you want. So you can actually make a 56 by 56-inch slide. PowerPoint is by definition 300 DPI. So a 56-inch slide is 56 times 300 dots per inch wide, which is, I don't know, 20,000 or something. So what it turns out is my local camera shop, I think a lot of them would do a matte 4x6 print for 70 cents.
Ah,
And so
okay.
what I do is I do a PowerPoint slide because it's 4x6. If you do a PowerPoint slide that's 24 by 18, when you now basically turn that into a PNG image to submit for them to print, it's 1200 DPI. When they print it on their 600 plus DPI printer, their photo quality printer, you get great images. And so you're taking something on the internet that you're finding that's 1,000 pixels wide, you're shrinking it down to something that's really small, but it still has a lot of pixels. And
Hmm.
so basically you just go find everything you want for a time period. And I kind of walk through it, so you do the typical search where you say, 1929 calendar, you know, and start getting, and then you find some images, then you basically, I put them into a PowerPoint and you put some guidelines on so you can see where 1 inch lines, so you can kind of scale some things, and then you produce them. And what I do is I always produce 2 copies for the second 70 cents. It costs more, it costs an order of magnitude more to drive to the Photoshop than the extra 70 cents to get a second one made.
Yeah.
So
Interesting concept.
no, it's an interesting thing. One of the things is PowerPoint's one of these things so many of us have, and it's a great little tool you can use.
Okay, thanks.